welcome to Science Access. In today's class, we're going to be talking about speed, velocity, and acceleration. Now, we'll quickly discuss distance and displacement before we talk about these things. If you know you are new to this channel, please kindly subscribe. Now, when you hear of the word distance, I move from a point A to a point B without regard to the direction. I'm not concerned about the direction, so that is distance. So the total length from the point A, the movement of an object from the point A to a point B without regard to the direction. You are not concerned about the direction. It's called what? Distance. Now, what about if I move from a point A eastward? See, this arrow is indicating the direction to a point what? B. Now, in this case, I'm concerned about the direction. So the total length from a point A to point B, which why I'm concerned about the direction, or with regard to the direction, in the particular direction, is called what? Displacement. So distance is the total length without regard to what direction, or when you're not concerned about the direction. Why displacement is distance in a specified direction. You're concerned about what? The direction. So that is displacement. Please take note of that. Now, what about speed? If you move from a point A to what? A point B, the total length and all over the time at which it takes to get to that total length is called what? The speed. Note again, the rate of change of what? Distance with time. I'm moving from a point A to point B. That is distance, right? The time it takes for me to get to this place. So the distance all over the time, which is the rate of change. How will you now define speed? The rate of change of what? Distance with what? Time. That is what? Speed. All right, so I can put speed this way. Speed is equal to distance all over time. So that is speed. Distance over what? Time. So what about velocity? Velocity is displacement over time. Now, remember, distance, you're not concerned about the direction, so that is a scalar quantity. While displacement, you're concerned about the direction, that is a vector quantity. Speed is also a scalar quantity, while velocity is a vector quantity. Please take note of that. Now, let's just assume, let's take a little bit of calculation. This is just an introductory class, so let's take a little bit of calculation. We assume that an object moved from, or a car moved from a point A to point B, let me say 300 meter, all right? 300 meter. This is the distance. For example, in 10 seconds, in 10 seconds, calculate the speed or calculate the velocity. It's simple. Speed is distance. What is the distance? 3 all over what? Time. 10. So if you this cancel, what is your answer? 30. Remember, this distance is in meter, right? Meter. Time is in seconds per what? Seconds. So that's your answer. If you ask to calculate for the velocity, it's the same thing. Is displacement, which is also the distance, all over what? Time. Take note of that. It's a very simple concept. What about if I use this same? I made mention of the fact that is the distance traveled is 60 kilometer, and the time that it takes to get there is what? Sorry, kilometer. And the time it takes to get there is what? 20 minutes. Now, if I ask you to calculate the speed, for example, you have to convert this to what? Meter. You have to convert this to seconds. How do you do that? It's simple. To convert 60, you just 60 times what? 1,000. And your answer is what? 60,000. Take note. To convert kilometer to meter, multiply the value with what? 1,000. Why? To convert minutes to what? Seconds. Multiply with what? 60. So 20 times what? This is kilometer, right? So 20 minutes equals to 20 times 60, 1,200. So this is in seconds, and why this is in meter. So you've got your answer. So to calculate the speed is now equal to what? The distance, which is this 60,000 meter all over the time, which is 1,200. This cancel this, this cancel this. This here, you can use your calculator to do that, and at the end you have what? 50 meter per what? Seconds as your answer. So it's a very simple concept. Now, introduce it to some terms such as uniform speed, uniform velocity, instantaneous speed, instantaneous what? Velocity. I will have to use a graph to explain this, and even introduce you to how to make a distance time graph and all that. So I will just introduce it. Let's just clean the board. So let's draw a distance time graph. Let's take a look at this graph. I have a graph like this and go straight first, then curve straight. This is just for teaching purpose, all right? Let's straighten it up. You have here as 0, here as 10, 20, 30, 40, 50, and 60. So here is distance, D in what? Meter. Okay. Then here is time. So let's form 2, 4, 6, 8, 10. So okay, 12, 14. Now, let's just take a look at this simple. This is time here in seconds. So note the fact that here is distance, here is time. So this slope, if you calculate the slope here, what you get is actually speed. For example, if you decide to take a point like this, 2 points, 2 points like this, here is 30, here is 20. So 30 minus 20, take it down like this, take it down like this. You have all over 6 minus 4, 10 all over 2. What do you have? 5 meter per second. So the slope actually gives the speed. But I want to explain something else. The slope of a distance time graph actually gives speed. I've explained that, but let's take a look. You have some terms like uniform speed or uniform velocity. When an object or a car, for example, move equal distance at equal time interval, is called what? A uniform what? Speed or velocity. For example, the car moved for 10 meters in how many seconds? 2 seconds. Another 10 meters. Now, between here and here is another 2 seconds. Another 10 meters. Between here and here is another 2 seconds. So for every 10 meters, it uses 2 seconds. The car have what we call a uniform speed or a uniform what? Velocity. It's a very simple concept. Now, it means that the velocity or the speed is not actually changing. You calculate from here to here, for example. You have 10. For you to get to 10 meters, how many seconds? 2. So it's 10 all over 2. What is the speed or velocity? Is 5 meters per whole seconds. So from here to here is 20 minus 10, which is also 10 again. 4 minus 2, which, so you now have, from here to here, you now have 20 minus 10 all over 4. Look at it here. Here is 4. Then 10 is what? 2. So 4 minus 2. What do we have? 10 all over 2 again, which is 5 meters per what? Seconds. If you do the same for this place, you get the same thing. If you do the same, so, but for this curve, look at this curve here. You can't do that. So the only way you can do is to calculate for the velocity at any moment. So the velocity at that moment is called instantaneous what? Velocity. It is not uniform. This place have a variable. The velocity is what? Actually changing. So I'm saying the velocity, the rate of change of distance with time is what? Changing. So actually the velocity is changing. So here, all this velocity, all the speed is what? Changing. So, but take a look at this place. Take a look at this place. This is a straight line. Now here, let's assume that here is 60, which is a little bit high, but let's just assume that if you draw it to that place, you have 60. So you have 60 minus what? 60 all over. Now the time here is 14 minus 12. So you have 0 all over what? 2. What is your answer? So the speed here or the velocity here in this flat line here is 0. So you can be given a graph and you are asked these simple questions. It's very easy. A distance time graph gives the slope of a distance time graph actually gives the speed. The slope of a displacement time graph gives the velocity. The slope of a velocity, if I decide to change here, which we are going to explain in the next one, the slope of a velocity time graph gives what? Acceleration. So let's now talk about acceleration. Let's change this place to velocity. Then here will now become meter per what? Seconds. Per seconds. Here still remains time. So you realize that acceleration is the rate of change of velocity with time. The rate of change of velocity with time. All right, so acceleration is change in velocity all over what? Time. So remember, velocity have initial value and final value. For something to change, there is an initial value. There is a value before and there is a value after. For example, for me, if I change my position, I was in a particular position before, I'm now in a new position. So we can replace this, we can rewrite this formula as v, which is the final velocity, minus what? The initial velocity, all over time. So this is also the formula for what? Acceleration. Now, this place that is still a straight line is also a uniform what? Experiencing what? A uniform acceleration. How do you know that? So if I decide to calculate just this place alone, I realize that 10 minus 0 is 0, 2 minus 0. So I'll also have 5 meter per second square. Remember, the unit of acceleration is meter per second square. So let's just do it. We now have 10 minus 0 all over 2 minus 0. What do we have here? 10 all over 2. So we now have 5 meter per second square. So if I decide to calculate the acceleration from here to here, or the greatest from here to here, which you now have 20 minus 10, and you also have what? 4 minus 2, just the way you have. So it's also uniform. Remember again, velocity time graph gives the slope, actually gives what? Acceleration. Because velocity is changing here and all over what? Time. And take note of the fact that this straight line here, or this, I will call this straight line, this is a uniform what? Acceleration. Here, the acceleration is what? 0, just the way we explained before. Here, it is coming down, which is deceleration. Take note of this simple fact. Now, it's actually this formula that gives rise to one of the equation of motion. You have A is equals to V minus U all over T. Just cross multiply. You now have, if you just want to multiply this, then you now have V minus U. If you just want to multiply this, what will you have? AT. Take this minus U, take it to this side. You now have V is equals to what? U plus what? AT. Remember, if this one crosses the equal to sign, it becomes positive. So this is one of the equation of what? Uniform acceleration. So in our next class, we'll be dealing with real questions and answer. I will now introduce you to what? The calculations in motion. So a very simple concept. Thank you. Please take a look at some of the questions that have been displayed on the board. Solve it. Drop your answer in the comment section, or you can drop your answer, send your answer to the email being displayed on your screen. Thank you for watching. Please subscribe.